All right, everyone. So we're continuing on day 2 of solving quadratics by factoring. And for this lesson today, sometimes we have to look first if I can take a greatest common factor out. And if not, we'll have to look at how else can I factor these trinomials. So for the first example here, I have 3x squared plus 9x minus 12. Well, I know that 3 is what we call that a term. Remember, standard form for our trinomials is ax squared plus bx plus c. And each ABC stands for the coefficient or the constant in the case of c. So our a is 3, and I want to see if I can't get this to go into my b and c terms. And thankfully for this one, 3 goes into 9 and 3 goes into 12. So I can take a 3 out of all of these. Now it's still there. I'm not getting rid of the 3. It's still there. So I'll have 3x squared when I divide that by 3. 9x divided by 3 would give me 3x. And negative 12 divided by 3 would give me a negative 4. And that equals 0 if we're trying to find those solutions. Now, to continue finding the solutions, I have to factor this part that's inside now. So I would take my x method again. I want to multiply on top, add on the bottom. Now, for the top part, we're multiplying to get the negative 4. Don't forget to take the negative with it. And we want them to add together to give me 3. 4 only has 2 pairs of factors, 1 and 4, 2 and 2. And I know 2 and 2 won't add together in any way to give me a 3, so it has to be 1 and 4. One of these is going to be negative, and since 3 is the positive, I know that my smaller of the factors has to be the negative. So we'd have negative 1 and 4 as my pair of factors. So now instead of having one long thing in the parentheses, we'll have 2 small sets. And don't forget your 3 out in front. It's still there, hasn't gone anywhere. And then we'll have x minus 1 and x plus 4. We're just plugging in those factors just as they are, and that equals 0. So for your assignment today, this would be our final answer in these parenthesis sets. But if you're asked to find the solution, not just the factors, we would need to continue solving this. This is where we're going to get rid of this 3, because multiplying 3 by this to get 0 won't change anything. So we can divide both sides by 3 to get rid of that. So I'll have x minus 1 times x plus 4. Again, I'm going to split these up into 2. So I'll have x minus 1 equals 0 and x plus 4 equals 0. Solving for x, I would add 1 to both sides to get x equals a positive 1. And for this one, I would subtract 4 from both sides to get that x equals a negative 4. Again, I can use those curly brackets, or we can just say x equals negative 4, positive 1. So in Delta Math, they're going to ask you for the factors, not for the solution. However, sometimes you might be asked for the solution in the future, so it's good to remember how to do that as well. Let's take a look at some other examples though. Sometimes you'll run into an example that doesn't work with our x method and we can't take a greatest common factor out in order for it to work. So that's where using the quadratic formula comes in really handy. So remember, our standard form is ax squared plus bx plus c. And that's going to tell me what my solutions are for these trinomials. So let's just give a try at this here first example, and then we'll maybe do one of the other examples too. First, I need to figure out what term is which. I like to list out my A, B, and C so that I can keep track of them when I plug them into my formula. Well, A, whenever you see a single variable, we know the coefficient in front is 1. B is 6, but it's minus 6, so this B is a negative 6. And C is a positive 4, so C equals 4. Now I'm going to plug all of those numbers in up here. So we'll have x equals negative B, so a negative of negative 6, plus or minus, because remember, when we take the square root of something, it could either be a positive times a positive or a negative times a negative. So that's why we need the plus and the minus in here. B squared, negative 6 squared, minus 4 times A, which is 1, and C, which is 4. And that's all divided by 2 times A, which is 1. Now, I want to simplify as much of this as I can. So first, I would see that I have a negative negative, which will become a positive. So I'll have 6 plus or minus. I'll still use my square root here. If I have negative 6 squared, negative times a negative would give me a positive, and 6 squared is 36. Minus 4 times 1 times 4. Well, timesing by 1 doesn't change the number, so we have 4 times 4, which will give us minus 16, and that's divided by 2 times 1, which just stays as 2. Moving up here, I want to simplify what's in my square root, so I would have x equals 6 plus or minus. Now, I know that these two numbers are perfect squares. However, remember that a square root doesn't just take the square root of each number. You would have to take the square root of the whole thing all at one time. So it doesn't quite work the way that we want to because of how exponents work. So we need to simplify what's in here and then take the square root. So this would become the square root of 36 minus 16 would give us 20, and that's divided by 2. Now, there's a couple of ways you can do this. You can either simplify this into the simplest radical form, which we do that by factoring 20. So we would have 1 and 20, 2 and 10, 3 doesn't work, but 4 does. It's 4 and 5. I know those are all the factors because I would continue back through this loop to get up to 20 once I've reached the next number. The reason why I list the factors is because I'm going to take the square of both of those factors. And so that means I want one of them to be a perfect square. So remember back to when we simplified our radicals. We want a perfect square to go into this radical. And I know 4 is a perfect square. And this actually works out really nice because 5 is another number we've talked about. It's prime. So I would replace that square root of 20 with 6 plus or minus the square root of 4 times the square root of 5. Remember, we're putting them both in the square root sign, divided by 2. And we know the square root of 4. The square root of 4 is 2. So we'll have x equals 6 plus or minus 2 square root 5 divided by 2. And hopefully you've noticed that 2 goes into 6 and 2 goes into itself, 2. So dividing both of these by 2, I would get that x equals 3 plus or minus the square root of 5. So you'd have two solutions, one where you're adding the square root of 5 and one where you're subtracting the square root of 5. For me, this is a fine answer. However, I think Delta Math is going to want you to find the decimal form of this. So to do that, you would punch these into your calculator, type it in online, however you want to do that, and you would get the solutions of 5.24 and 0.76. Let's take a look. All right, so we've talked through the greatest common factor method, we've talked through the quadratic formula, but sometimes it might be easier to use a little bit of a different method, kind of a combination between all of those. So let's take a look at this here, problem number 4. So this one has a coefficient of more than 1 for our a. So we have our a x squared plus bx plus c. We have 5x squared minus 8x plus 3. Now, I would want to take out a greatest common factor, but 8 and 3 are not multiples of 5. So I can't take a 5 out of everything, so I can't use that method. And I don't really want to use the quadratic formula because some of these numbers just seem a little wonky. You can still certainly use it, but there's a little bit of an easier method here. We can actually still use our x method, and we're still going to multiply and add, but our numbers are just going to be a little bit different. For a, we're going to take the 5 and the 3 and multiply those two together to get 15. But they're still going to have to add to give me negative 8. So I'm going to list my factors 1 and 15, 3 and 5. Now, if my 15 is positive, but my adding term is negative, that tells me that both of my factors also need to be negative. So I'll have a negative 3 and 5 because I know 1 and 15 cannot combine to give me 8, but 3 and 5 will. So the way that I would write this next is 5x squared, and then these two terms here actually become the middle term separated. And I know how I want to split these up. I'm going to strategically place these so that they match up with their like terms. I know that negative 5 and 5 have a common multiple, so I'm going to have 5x squared minus 5x. I also know that this plus 3 is going on the end here, and that negative 3 has a common multiple with 3. So I want to group things with like numbers. So now I would take my left side and my right side. These are not multiplied but added together. And I want to take out as many common terms as I can from each of these. Well, 5x squared and 5x both have a 5 and an x with them. So I'm going to take out a 5x from both of those. And when I do that, I'm left with 1x here. And 5x divided by 5x would give me a minus 1. They would cancel each other out, and since 1 was negative, it stays negative. However, for our other side, we have a negative 3x and a positive 3. So I know that I can take a 3 out of both of those, and when I do that, I'll have a negative x plus 1. But something's not right here, because I have two pieces of a puzzle, but what I really want is for these two parenthesis pieces to be the exact same thing. However, I can easily change that because I have a negative and a positive of the same things, they're just flipped around. So what I can do, instead of just taking out a 3 from the right term, I can take out a negative 3. Dividing a negative 3x by a negative 3 will make this a positive x, and dividing a positive 3 by a negative 3 will make this a negative 1. So now instead of negative x plus 1, we really have x minus 1 for our parentheses there. And the reason why I do that is because if these two terms match up, this is like 1/2 of our distributive property being used. So I can undistribute these first two terms from their parentheses and write them in their own set. So I'll have 5x minus 3 as its own pair, and then I'll have x minus 1 as the other pair. I can show you how that works by saying if I were to take just 5x and say that I want to multiply it by the other side, I would have 5x times x minus 1. But I still have this negative 3, so I would need to write that too as negative 3 times that x minus 1. So plus negative 3 times x minus 1. That gets me right back to this step I had here, which can work me backwards to here and back up to my final trinomial. So this here would be the final answer for my factoring of this trinomial. As always, if I wanted to find the solution for this, I would set both factors equal to 0. So I would have 5x minus 3 equals 0, and x minus 1 equals 0. To solve for x here, I would add 3 to both sides. 5x equals 3. Dividing both sides by 5, I get that x equals 3/5. And for this one, I would have plus 1 to both sides to get x equals a positive 1. So my two solutions would be 3/5 and 1. Again, for your Delta Math assignment, they're just going to ask you for the factors. So you're going to want to use this set up right here instead. If you have any questions, need help with anything, please don't hesitate to ask. See you next time.